Hello and welcome to the first development log of what is currently known as the VEX Virtual Builder. These videos are part of a long series that is meant to catalog the progress in the development of this software. For testers, these videos can be a reference for updates and a tutorial for using new and current features. To make it easier to go through, you may notice that this video is split into chapters, which you can click throughout the video on YouTube. These are also listed in the video description. Also, just remember that this is not the final product. Everything shown in this video may be subject to change. So let's get started with devlog number 1. So we'll start off by going to the right of the screen, where you'll see a large panel containing a list of all the parts available to use. You can use the tabs to organize by structure, motion, or electronics. Beyond that, you can also directly search the entire list of parts. Each part is shown in its own box, with options for different types and sizes for each part. Clicking on arrows goes through each of the options, and simply clicking anywhere on the box will add the part to the build area. For example, I'll go ahead and add a 1x3 15-hole C channel to the build. Within the build area, you are able to control the camera and what you see while you work. Starting from right to left, this is the orbit control. Clicking and dragging around allows you to orbit the camera about a point in 3D space. Clicking on the middle mouse button also does this. This is the zoom control. Clicking and dragging up and down allows you to zoom the camera in and out. You can also use the scroll wheel. This is the pan control. Clicking and dragging around allows you to shift the camera's view. Pressing shift while clicking the middle mouse button also allows for this. Over here is the orthographic control. Clicking on it enables the orthographic mode, which is a specialized view of the camera that flattens everything out. For example, if I look at the C channel in orthographic mode, the view flattens, allowing for a careful adjustment in 2 dimensions. Finally, we have the focus button. If you ever find yourself using the orbit tool and notice that it doesn't seem to rotate about a part, simply select a part, shown by the blue outline, and press the focus button. This moves the camera to focus on this point, allowing you to orbit about its center. Next up is arguably the most important area, and it's the tools sidebar shown in the left of the build area. Every time you select parts, the tools shown here will change as they become available. We'll start off with the tool that every object has available, the transform tool, which allows you to directly manipulate the rotation and position of whatever you have selected. Let's go ahead and enable it by clicking the associated button right here. As you can see, a group of arrows and rings appear at the center of the selected part. Clicking and dragging an arrow allows you to move the part along a major axis. You may also notice the rings on each of the arrows. Once again, clicking and dragging around the ring itself rotates the part about the arrow's axis. Now for some specialized tools, this time for screws. Whenever a screw is selected, the Insert Screw Tool button appears, which allows you to insert screws into holes. So let's go ahead and add a 1/2 inch screw to the build, and we'll move it out in front of the C channel. Next, let's enable the Insert Screw Tool. You'll notice a central button and 2 arrows are now located at the center of our screw. Clicking and dragging the center button to a hole and then releasing the mouse will automatically move the screw to the hole. The arrows allow for more advanced movement, but before we get to that, let's go ahead and add a flat bearing to the build and move it in front of the C channel with a transform tool. Next, we'll move the screw to a hole on the bearing. Clicking the arrows allows you to move along the list of objects on the screw. So let's press the arrow on top to include the bearing, indicated by the outline. And now, we can use the Insert Screw tool just like we did before, but this time, the bearing will join the screw on the hole. Also, clicking on the center button instead of dragging enables a ring that allows you to rotate about the screw's forward axis, rotating any objects included as well. Before we take a look at the next tool, we'll need to add some objects to the build. Let's add a 1/2 inch screw to the build and move it next to the last screw we worked with. Now, let's add a motor to the build. Let's move it behind the C channel. Then we'll select this hole on the motor. You'll notice that the Move Hole tool now appears on the left. Enabling it shows a similar central button to the Insert Screw tool, but this time without arrows. Clicking and dragging the center button and then releasing the mouse on a screw allows for the hole to move to the end of that screw. Also, like the Insert Screw tool, you can click on the center button to rotate about the hole with the ring. So now that we have our basic structure, you'll notice that it's all separated and each individual part can be moved. To connect it all up, we'll use the screwdriver tool. This tool acts much like its real-life counterpart, enabling the tool turns all loose screws red and all tight screws green. Let's go ahead and click on a screw to tighten it. Turning off the screwdriver tool returns everything back to normal. We can now select any of the parts we just put together, and you'll notice that they all act as a group. Using the transform tool, you can see that they all move together. Now let's take a look at working with shafts and motion objects. Let's go ahead and add a 3-inch shaft to the build, and you'll notice that the insert shaft tool appears. Much like the previous insert tool, clicking and dragging the center button to a motor or a hole will move the shaft. In our case, let's just move the shaft to the motor. So now that we have our shaft inserted, let's work on adding some parts to that shaft. We'll start off by adding a 1/2-inch nylon spacer to the build. You'll notice that there's an option for the shaft axis tool. To use it, simply click and drag to your desired shaft, and while still holding down the mouse button, release on the arrow moving the spacer to the desired location along the shaft. You can see here that the spacer is now perfectly placed on the C-channel using this tool. The great thing about this tool is how great it fits into harder to reach areas. Let's take a look at this by adding a normal shaft collar to the build. We'll orbit until we see the area between the motor and the C-channel. Let's go ahead and use the shaft axis tool right in between that area and put our shaft collar against the C-channel. For our final few steps, we'll go ahead and add a wheel to the shaft. Let's go ahead and add another shaft collar and a 4-inch traction wheel to the build. We'll use the shaft axis tool to move the traction wheel right next to the spacer, and again on the shaft collar right next to the wheel. Taking a step back, we created a small assembly of a motor attached to a C-channel with wheels, spacers, and shaft collars, all done with intuitive and simple to use tools in just minutes. That's about it for this video. I hope you enjoyed getting to know the current state of the VEX Virtual Builder. While the VVB is still in a private beta phase, you can rely on these videos to get updates on development before and after a public release. Don't forget to like and subscribe to stay updated on the development and other news on the VVB. Thanks for watching.